well, we're here with Dr. Ellen Towns Anderson, one of Dr. Charles Towns' four daughters, are here at the Rutgers, New Jersey Medical School, and want to thank you so much for your time and agreeing to share some insights. It's an important time.
My pleasure.
How are you and your family handling all this, the acclaim and the remembrance now of the event at Berkeley's coming up in a couple of weeks?
Well, he was 99, so it wasn't a shock. Although when he died, but he wanted to live very much to 100. So one of his colleagues figured out that he had actually lived 99.501 years, rounded up would be 100.
Yeah.
So we enjoyed that joke and felt better about that. It's still always a loss, and we had a wonderful service at his church in Berkeley, and we're able to interact with the minister and provide vignettes of our father and our life with him, and share a religious service, which, he attended church very consistently. He prayed and read the Bible every day of his life, as far as I know. So, because he was fairly advanced in age, I think that helped in losing him. But we recently, as a family, also buried half of his ashes up at his farm in New Hampshire, and that was just the family, and that was wonderful. The other half will be buried down in South Carolina with his southern relatives, his mother and father and so forth.
Well, you were just we're talking briefly about the event, the two-day event that's going to be held in his honor at Berkeley. Lasers, Light, and Legacy, I believe it's called.
Yes.
Although the organizer had said that lasers are perhaps a smaller portion of the focus, given that so many people know his legacy, but his influence is much broader, and his interests were far broader.
Right. Well, when he went to Berkeley, he really changed fields into astrophysics and astronomy, and made several fundamental discoveries. As far as I know, I'm not really an expert on his scientific legacy, but in discovering molecules in space, including ammonia and water, and then working on discussing the presence and size of the black hole at the center of the galaxy. And at the end of his career, he was looking at the changes in the size of stars. And with all that, he was using lasers, but his questions were quite different. And I think he always felt that it turned out to be a wonderful transition. He liked to move to new things. He said that, many times himself, that, 10 years in one area is enough. I got to move on and do something else. So when he moved to California, that was a transition into other areas, where I think he made significant contributions as well. And he was developing some telescopes that used large mirrors and lasers to be able to sort of pinpoint things in space, and was using infrared in photometry, which I think kind of opened up a new field, and some of his colleagues are still using that technique. What was your question?
We were just talking about his
broader legacy.
Broad spectrum
Right.
of legacy and,
Right.
and interest.
It's interesting that one of his postdocs went into neuroscience, even. So they didn't all stay in physics or astronomy, and some went into industry, some started businesses. So he had a lot of students, and in that way influenced a lot of people, and many of them went on to do wonderful things. So it was a broad legacy, I would say.
And you said actually a lot of the people who will be speaking on day one of this event are a lot of his successful grad students, and their information will be news to you as well a little bit.
Absolutely, because as I said, family was not in the lab. So we didn't know that much about what was going on in the lab.
Now you're one of four siblings, or yes, you have three sisters.
Right.
Did any of the others follow into your path into sciences?
Well, my older sister is a developmental psychologist, and recently working in a home for troubled children with autism and so forth. Then there's me, and I call myself a neurobiologist. And then my next sister was a teacher, middle school teacher, and some years she taught science, but her specialty was English. And then the youngest daughter, my youngest sister, is a mechanical engineer and works on energy conservation with a company that looks at commercial buildings. So in some ways, we all touch on science, maybe not directly, but obliquely. I'm probably the most directly scientific academic. But all my sisters had advanced degrees, and my parents thought education was extremely important and encouraged us and supported us in that. So.
You say you weren't in the lab as a family, of course, but how did your father impart his curiosities, or was it kind of natural, or did he impart particular lessons to you? And your mother, if I may say as well, also has some particularly deep interests. And
she does. Well, I'll give you an example of how he imparted sort of a general interest in science and the natural world. I think that's where we interacted with him more. In middle school, I was doing a project on spiders for my biology class. And so he helped me for several weeks go out into the yard and collect spiders. And we put them into jars, and we kept them alive, and one of them had babies and so forth. And so, just his enthusiasm, because frankly I didn't like spiders, still don't like spiders, but doing it with him was lots of fun and kind of, made me much more enthusiastic. And of course, eventually I went into biology. So, and so he did that, I think, with all of us, worked or played with us in terms of the natural world. And when he bought this farm, one of his hopes and visions was that we would have more of a chance to experience the natural world and explore, and that we and our children and our children's children. So he felt exploration was wonderful. But he was a very upbeat, curious guy who loved to play. And play is really a form of exploration, and so he would play with us all the time, and he loved sparklers and dressing up and roughhousing and so forth. And so all of that, I think, was the spirit of sort of enthusiasm and enjoying life and the world and exploration.
When did it kind of begin to sink in that your father was kind of a big deal in the scientific world? Did any of that kind of trickle in?
It only trickled in when he got the Nobel Prize. I really didn't know. I mean, he was provost at MIT at the time, which was a significant administrative position. I was aware of that because I was dating an MIT student. But sort of an international prominence, no, we didn't have a sense of that until the Nobel Prize. And we all got to go to Sweden and dress up, go to parties, and we met Martin Luther King. It was the same year that Martin Luther King Jr. got the Peace Prize. So I think it really wasn't till then, and I was in college, so it was somewhat later in life for us. And I think, thankfully, I'm not sure having celebrities for parents is certainly not necessary, and I'm not sure it's that helpful, actually. You just want them to be your parent. So
Sure.
yeah.
Both your parents wrote memoirs. Your father wrote about how the laser came to be, and your mother wrote about being the adventures of a scientist's wife, essentially. And she has advocated for youth. And I'm just wondering if you had a part in reading those books or helping edit those books. And
No.
okay.
My mother, though, you're right, she all her life did volunteer things. And when she moved to Berkeley, she felt moved to get involved with homeless youth. It was a big problem. They were there in the 60s, a lot of agitation going on, a lot of young people moving to Berkeley, and homelessness of young people was a big issue on the streets of Berkeley. And she took that up and continued that for many, many years, raising money. Actually, some of the Templeton Award that my father got went, to that cause. And worked with housing them and feeding them and being with them. She is a very approachable, non-judgmental, open kind of person, and was able to relate to them in a way that I really admire. And she's always, as I said, kind of been involved in social activities, and I think that spilled out to all of us. All of us have also always been involved in various kinds of non-profit organizations and other kinds of things to help one way or another.
Speaking of documentation of your father's history and your family's history to some extent, I'm sure you're aware of the oral history interviews conducted in 1991, 1992. They reside at the Bancroft Library at Berkeley. I'm just curious if if you had read through all those, or if we'll be sending people over to read it. It's quite candid and extensive.
It's a tome. My father always sent us things that he published and speeches and so forth. I tended not to look at those too much, and I felt close to my father, and when I was in Berkeley at school, I would have dinner after church on Sundays with him every week, and I guess I preferred the living person. Since his death, I have started to look at some of that stuff and realized that there were things about him that I didn't know, and maybe wished I'd known more. But at the time, I just was present. It was in the present. And I don't know about my other sisters, but I'm guessing it's a similar sort of thing. So we have all those things to look at, as well as our own memories and family photos and so forth. So that's kind of nice. We have a rich depository of things to jog our memories or even create new ones.
Have you ever had occasion to use a laser in any of your work?
Yes.
Huh?
In the mid-90s, my father always asked me about my work, and always said, please send me your published papers, which I did, and he would always say, oh, they were very interesting, but I couldn't understand them. But in the mid-90s, he said, have you thought about using something called the optical trap, or the optical tweezers? And I kind of said, well, no, and I kind of looked it up and thought, and he helped me set up a meeting with Arthur Ashkin, who was the inventor of the optical tweezers. I was working at Cornell at the time, in the Department of Physiology there, and my colleague and I went out to visit Arthur Ashton and see his optical tweezer setup and everything at Bell Labs. And he showed us images of tweezers interacting with biological material and nerve cells. And I had developed the idea that we might be able to move nerve cells. So I was able to get money from NIH to try this out, and bought an optical tweezers set up by a company that was kind of a startup company. And we proceeded to try to move nerve cells. And I would occasionally see my father and show him the videos of what we were trying to do, and cells were spinning out of the trap, and it kind of wasn't working. And eventually we were able to develop a substrate on a glass plate to which the cells would not stick. So our biggest problem was that when you put cells down, they wouldn't remain in suspension, they would slowly sink down, and then they would stick. And the tweezers was not powerful enough to overcome that adhesion. So we developed a substrate that was completely non-adherent to the cells. And the substrate is the same thing that's used for contact lenses. So the contact lens will not stick to your cornea. And then we started to be able to pick up whole nerve cells, and these were huge neurons. They came from salamanders, and salamanders have the largest nerve cells in the vertebrate kingdom. So these are very big cells. And we picked up all kinds of cells. And then we developed experiments saying, well, if we can pick them up and move them, maybe we can create clusters of nerve cells that of our choosing to watch their interactions, which we proceeded to do. And we published a paper in which I cited two of my father's papers, and I've never since been able to cite, we just are in different fields, because he had written a paper saying that the optical maser should be useful in medical practices. And then I subsequently did more work with the optical tweezers, and now I've had a graduate student who's worked on using the optical tweezers to move nerve cells on a microelectrode array, so that we can place nerve cells at precise points on the electrodes, which isn't possible. Usually they just drop nerve cells onto a microelectrode array and the placement is very random. But with the tweezers, we were able to move them, and we had to get special MEAs that you have to use particular kinds of glass and so forth. But anyway, it all worked, and that's not published yet. So he started me on that, you asked, and it's not a main thrust for me, but it turned out to be really a lot of fun. And I think we're the first to move whole nerve cells. People have moved parts of nerve cells, but not the whole thing. So anyway, it was fun sharing with him. I would bring the videos and say, well, what do you make of this? Or what do you think is happening here? And mainly it was his interest that he gave me. He couldn't really give me a lot of answers. So we just plowed on and eventually made it work. So, yeah. So that's a little piece of kind of collaboration that I treasure.